Hey guys, today we will be working on Algebra 1 Exponents and Radicals. I respectively scored a 780 on SAT Math and I have an average of 100 on AP Calculus AB. I also offer tutorings. If you're interested in tutorings, you can contact me on the description down below. So before starting, don't forget to hit subscribe and like the video for more, and let's get started. Alrighty guys, welcome everybody. So today we'll be working on exponents and radicals. So first of all, we have a question. What is an exponent and why do we use it? Guys, there is numbers, right? Like 2, 3, 4, right? And sometimes you have to multiply these numbers with each other, like 2 times 2 times 2 times 2, for example. And therefore, sometimes I have to multiply these numbers too many times that I can write in a one-line sentence. Therefore, we use exponential expressions in order to represent this state, which is, let's say, 2 to the power 4, which is equal to 2 times 2 times 2 times 2. We multiply 2 4 times, guys. So about exponents, there's a very common mistake. Many people tend to make this mistake, especially if you just started learning exponents. They usually, what they do is 2 times 4, because they just take the base. This is what we call base, and this is what we call exponents. Exponent. And they just multiply the base with the exponent, which in this case will be 2 times 4, and then we just go say 8. But is this equal to 8? Definitely not, guys. So you have to make sure you don't make this mistake. And the difference between multiplying and exponating is basically, if you're multiplying 2 times 4, this is actually representing 2 plus 2 plus 2 plus 2. Basically, the multiplication symbol is representative of adding. Okay, so basically this is a sum of 4 times 2, which is we're adding 2 4 times. But over here, when we're taking the exponent, we're multiplying 2 4 times with itself. That's the difference between multiplication and exponential expressions. Also, this would be a helpful information if you're planning to make a career in mathematics. A linear graph, which we call like just something multiplied, let's say 2 times 4, x. We use x's in order to represent a variable, so we can have a change, which will represent a graph. So let's say we have 2 times 4, or just 4x, all right? So since we represent 4x, which is actually equal to x plus x plus x plus x, our graph would look like something like this, actually, something like this, which is going to be a linear graph. That's why, therefore, we call it a linear graph. And that's why the increment is always constant, guys, in this case, because we're multiplying things. But however, oops, in this case, in an exponential case, which we can call x squared, our graph would look like something like this. Okay, and the most important point of this is exponential expressions increase exponentially, like it increases with greater amounts every single time. So let's just demonstrate this, because I believe that the demonstration of how big exponents could get is a significant part of this concept, because most people just skip these exponentials by memorizing things. But however, I believe learning how exponential expressions grow, how fast they grow, and how they represent in graphs are such an important future of this concept. So in this case, let's say 2 to the power of 10. I'm just going to demonstrate how great it makes. First of all, we got 2. Actually, anyway, I would like to demonstrate how big the exponent symbols can get. So I would also like to demonstrate how big, how greater the exponential expressions can grow. So let me just show an example. Let me just demonstrate this. Let's say 2 to the power of 10. First of all, I have to know that 2 to the power of 10 is equal to 2 times 2 times 2 times 2 times 2 times 2 times 2. I already got tired. That's why we use exponential expressions, because I don't want to write all of this down. This is just nonsense, especially if you're dealing with harder equations. You're not going to write this. This is just nonsense, guys. That's why we use exponential expressions. This is a very helpful tool for us. 3, 6, 8, 9, 10. So this is 2 to the power of 10. And if we multiply 2 by 2, first of all, in this case, we got 4. And we got 4 times 2 is going to be 8. And 8 times 2 going to be 16. The first difference was 2. The second difference was 4, because 8 minus 4 is 4. And the second difference was 8. And next difference will be 32, which is 16. The next difference will be 32. And the other difference will be 64. So you know how great it grows now? It's 256, 5, 1, 2. I probably skipped 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. 10. I probably should have skipped one anyway, and then we end up with 1024. So guys, just after this part, it's gonna go to 2048. Okay, and it's growing very large amounts. That's why in graphs we first start with lower values, and then as the domain of our function, which is anything, any variable, grows, it will increase with a significant amount. That's why we use exponents. Now let's see how can we multiply and divide with these exponential expressions, guys. So let's say we got 2 to the power of 5. I use 2 because 2 is a very simple number and it's easy for many people to comprehend. Let's say 2 to the 5th power times 2 to the 2nd power. Okay, so first of all, let's solve for 2 to the 5th power. What is 2 to the 5th power? 2 to the 5th power is 2 times 2 times 2 times 2 times 2, which is 32. And 2 to the 2nd power will be 2 times 2, which is 4. Now, if you multiply 4 times 32, you will get 128. But you don't want to do this because this is a very long way to solve this type of question. What you want to do is if you have exponential expressions, you can add exponents together. If you have exponential, just make sure that you're not adding them, you're multiplying. But guys, you don't want to do this. You don't want to add and solve for this together. It's a very long way to solve this type of question. What you want to do is, if you're multiplying an exponential expression, what you have to do is you would say 2 to the 2 power. You can write this as 2 to the 5th power plus 2, which is also equal to 2 to the 7th power. Which means if you're multiplying two exponents and you have the same base, you can add the exponents together. So actually, 128 is equal to 2 to the 7th power, because we know that if the base is same and we're multiplying it, that means that we can add the exponents together. So awesome. If we can add the exponents together, if the base is same and we're multiplying them, then how are we supposed to divide exponential expressions? Very good question. If we have, in the same case, we have a same base, okay? Let's say 2 to the 5th power divided by 2 to the 2nd power. How can we solve this type of question? So guys, basically, you also know that we can just say 2 times 2 times 2 times 2 times 2 divided by 2 times 2. This will be 32. This will be 4. 32 divided by 4 is 8. Guys, don't do this. Like, I just did it, but you don't have to do it because there's a way more easier method. If we have the same base and we're dividing two exponential expressions, what we can do is you're just gonna say 2 to the 5th power minus 2, which will be 2 to the 3rd power. Why? Because we have the same base and we're dividing with it. That's why we can just do this and end up with 2 to the 3rd power, which will end up being 8. Remember, guys, it's not 2 times 3. It's 2 times 2 times 2. Now let's start with something new. So we just learned that we can add exponents by multiplying them if it has the same base, in this case 2 to the 7th power. Also, we can subtract the exponents if they're divided. In this case, this will be 3 to the 3rd power. The reason being is they're the same base, they're divided, so I just can subtract 2 from 5, and I can end up with 3 to the power of 3. Now, I have one more question. Let's say I have something, let's say it has to be, let's say, so I have another problem. Let's say I got an exponent under 1, which can be 1 over 3 to the 5th power. Okay, there's a very simple way to write this. Our great mathematicians just create a way more easier way to write something like this. If 1 over something exponent, we just can say take the base, which will be 3, and write your exponent as a minus on top of it, as a negative exponent, which will be 3 to the negative 5th power. This is how we write negative exponents. We have to, if it's 1 over something exponent, we can just say something, which will be our base, to the power of negative that exponent. See, let me just write this down. 3 is your base, and your 5 will be your exponent, guys. Don't forget this. And we just, as I said, can do this. Now, if I said 3 to the 8th power divided by 3 to the 5th power, you can also say 3 to the 8th power times 3 to the negative 5th power. The reason is because 3 to the 5th is under the fraction, and that's why we can just bring it up, and then we can just write it as a negative exponent. And then you know how to deal with multiplying two exponential expressions if they have the same base. We just add the exponents together, guys. And what is 3 to the power of 8 plus negative 5 is equal to? Obviously, it will be equal to 3 to the 3rd power. That's how we deal with this kind of questions. Also, yeah, as I said, since we have a division under that, you just can't get rid of this 5 and just subtract 5 from the 8 and just say 3 to the 3rd power. But make sure that you know this rule, guys, because this will be very helpful, especially in your Algebra 1 exams, or maybe you're taking some kind of regions. It will be significantly helpful for you to know this point. Now it's time to face our lovely radicals, guys. Radical is actually an exponent, which is not an integer number. Wonder, what can that be? Like, let's say 3 to the 2. First of all, what is an integer, guys? An integer is a number, a whole number. We just call it a whole number, like 1, 2, 3, 4. These are integer numbers, guys. However, let's say I got 3 to the 0.5 power, a decimal power. How can I write this? Maybe some of you can just say 3 to the 1/2 power. Very smart way to think about. But how are we gonna solve this? How are we gonna solve something like this? Guys, if we have something which is not an integer number in the exponents, what we can do is we just can write this as a radical. So we just can say square root of, why we're writing square root awesome? It's because you're dividing with 2, okay? So you're basically writing a small 2 over there. Mostly we don't write, because for 2, in this case, we just don't write it. There's just some kind of tradition, but actually it's 2, and we will have our base number inside that radical. So let me demonstrate another example of this. Let's say 3, or maybe I'm bored of 3. Let's just say 5. 5 to the 1/5 power, or maybe 1/6, doesn't matter. So 5 to the 1/6 power. How can we write that? Guys, it's so simple. Just take your 5, make a radical sign, and then write a little tiny 6 over there. And that's how you do it. So first of all, some of you might think how we didn't achieve anything. Actually, I can understand that argument, but in this case, it's impossible, not impossible, but it's very hard for some kind of human to, solve this kind of question, because you need a calculator, especially for greater numbers of fractional exponents. Remember, guys, radical means a fractional exponent. Fractional exponent. Therefore, what we can do is, especially if you're writing let's say I got 4 to the power of 1/2, okay? How can I solve this? So basically, guys, this will be radical 4, and solving this might be quite hard, but first of all, notice that you can write 4 as something else, which will be 2 times 2. In other words, it will be 2 to the power of 2. And in top of that, let's just say I want to write 4 as 2 to the power of 2. I just put 2 to the power of 2 as 4. So in this case, I just end up with 2 to the power of 2 all the way to the power of 1/2. Okay, that's what I got. And guys, remember, if you have, let's say, 2 to the power of 3, on top of it, we have power of 2. What we can do is we have to multiply these numbers together to get something like 2 to the power of 6. In this case, we have 1/2 and 2. So what we can do is we're going to multiply them to find the question's answer is equal to 2 base to the power of 2 times 1/2. And when is 2 times 1/2, guys? It's going to be 1. That's how we solve our exponential fractions. Actually, these are fractional exponents, in other words. So guys, if you're dealing with square root of 4, what you just can do is it's just 2. The reason being is 4 is the square of 2. That's why we write it as 2 to the power of 2 and divide it all to the power of 1/2. And we just multiply this 2 with 1/2 and just get 2 to the power of 1. And that's your answer choice. So let's just work on some of these exponent and radical questions, guys. So the first question is a to the power of b divided by a to the power of c. Well, how can we solve this type of question? So guys, as I just said, if our exponent is under the fraction, we just can write it as a to the negative c power. But first of all, let's just write our a to the b power and multiply that with your fraction under your fraction, which will be a to the minus c power. And after this point, it's very easy. You just can say a to the power of b minus c. The reason being is you're just adding these exponents together in order to write it as one exponential expression. Let's see. Over here, what we got is cube root of x to the power of 3. How can we solve this? So guys, basically, I want to write this as something else. How can I write it? X cubed all the way to the power of 1/3. Why? Because the cube root is equal to the power of 1/3. That's why we just multiply these exponents together, because they're exponenting each other, and we end up with x to the power of 3/3, which will be x to the power of 1. Over here, I got b to the power of 12, and also I got to the power of 1/3. So I just multiply 1/3 with 12, and I end up with b to the power of 12/3, which is equal to 12 to, b to the power of 4. Over here, guys, I got 2 to the power of 8 to the power of 1/2. All I got to do is multiply this outside exponent with the inside exponent, and I end up with 2 to the power of 8/2, which is equal to 2 to the power of 4. I'm sorry. Yeah, and over here, guys, this might seem like a complicated question, but it's actually not. So basically, we're asked to take a square root of a squared times b to the power of 6. How can we achieve this? So guys, first of all, if we have a multiplication inside this, what we have to do is we have to distribute this radical inside to the variables, or if you have constant numbers, doesn't matter. So what we have to do is a to the power of 2 to all the way to the power of 1/2 times b to the power of 6 to the power of 1/2. This is equal to that. And then we can now distribute our outside exponent to our inside exponent, and then we can achieve a more reasonable or more simple answer. In this case, we got a to the power of 2/2, which is 1, times b to the power of 6/2, which is 3. So our answer choice is a times b cubed. Over here, this is a very simple question. If we are multiplying exponential expressions and we have the same base, all we can do is just add these exponents together. And we got 8. Yay! So guys, as I go through, I want to go over a few more points of exponents and radicals before ending this lecture. So, one of the most important laws of mathematics is actually, let me just demonstrate this, in parentheses, a plus b squared. How will we write this? So guys, this is something, there are many ways to prove this, but I'm just going to show what it is. It's just going to be a squared. You're taking the first number squared, plus you're multiplying the second number with the first number and ending up with, and also multiplying with 2, and you're getting 2 times a times b, plus you're also adding b squared. How about if I said a minus b squared? In this case, I would get still a squared plus 2 times, plus negative 2 times a times b plus b squared. And there is one more law of this. A squared minus b squared is, we are able to write this as a minus b times a plus b, guys. So these 3 laws of using exponents is actually one of the most significant parts of mathematics, calculus, algebra, whatever you call, because there are in almost every kind of mathematics you would want to use this. So these rules, because it's very helpful. So there are many ways to prove how this is true, because actually, if we're squaring something like a plus b, we actually are, what we're doing is we're multiplying a plus b with itself 2 times, 1, 2. And how can I multiply like something like this? First of all, I take my a, I multiply with this, which is a squared. I multiply with b, so I got a plus b. And then after there's nothing else to multiply, I get to my second number. I get my b. I multiply with my a. I get ba, which is actually the same thing with ab. And I also multiply with my other number, and I got b squared. So I got a squared, 2 ab's, and b squared. Also, over here, a minus b is the same way. We got a squared minus, actually, let me just write it as minus over here. A squared minus 2ab plus b squared. This is the same way of solving. We just did the same thing, and we would end up with this, okay? And in other words, our last but not least law of exponents would be a squared minus b squared could be written as a minus b in parentheses times a plus b. And you also can prove this one too. It's very basic. So you can just take your a, multiply with this a, you got a squared, multiply with this a squared. Let's just write this down. A times b, you're just gonna write a times b, which is ab, and negative b times a, you're gonna get negative ba, which is actually the same as ab. Because guys, don't forget, if you want to write as 3 times 5 is equal to 5 times 3, So don't worry of the exact location of these variables. Also, take your negative b, multiply with b, and you end up with negative b squared. And this is actually equal to a minus b squared. So guys, we are asked to find this area of the shaded region. What can we do in order to find this area? So we have our b value, we have our 2. Over here we got our 2. We have another b, and we got 12 centimeters of length, or meters, if you may. And how can we find this area, this shaded area? The question states that this ABCD is a square, and DE is parallel to BA. So what can we do? First of all, guys, if this DE is parallel, if these lines are parallel, I just can say that this 2 is also, this will be 2 as well. And also, these lines are parallel as well. So I got this place will be 2 as well. This is a square of 2. Okay, so how can I find an area of a square? First of all, I want to find an area of a square. First of all, before doing that, the most basic way of solving this question is just finding the total area, and then we can subtract these other rectangle and square from this area in order to find our shaded region. Or if we find the lengths of that region, we just can multiply those lengths and just get our area from there. But is there any chance we can get it? So b is our variable, and this length will be b, this length will be b, and oh, look at that, we got b plus 2, this will be b, and this is 2, and this is equal to 12. So I got b plus 2 is equal to 12. So how can I find this shaded region? So if I know b, definitely I will be able to solve this square, because it's going to be b squared. So how can I do that? I just subtract 2 from both sides, and I end up with e is equal to 10. And that's how I get my length of this square. And after that, I just can say b squared is equal to 10 squared, and I end up with 100. The reason is because I have my length of b, and you can also treat this as a rectangle. You just can multiply the side lengths of a rectangle, and you can end up with something, your area. Don't use your parallel sides to multiply. Use a perpendicular sides of your rectangle. Even if it's a square, it doesn't matter, because a square is also a rectangle. So you just have to do b times b. If you do b times b, that's b squared, and you know that b is 10, so you just can't say 10 squared to solve this question. So in this problem, let's say that we face with something like this, 2 times radical 3 divided by 3 times radical 10. How are we supposed to simplify this? So basically, guys, we don't want to have any radicals under the fraction because it doesn't look nice, and it's usually harder for us to simplify. So what we have to do first is just, we're going to get rid of this radical sign down under the fraction, and after that, that will be a simplification of this function. Or not function, I'm sorry, this fraction, or expression. So I first of all will say 2 times radical 3 divided by 3 times radical 10, and I want to multiply this with radical 10 over radical 10. Guys, why am I multiplying this fraction with radical 10 over radical 10? Guys, radical 10 is equal to radical 10, right? So if I divide something which is equal to it, I would end up with 1. If I multiply something with 1, I'm not changing it. That's just changing it appearancely. So I just can make it more simple. It could make my life easier. That's what I'm trying to do. So in the top, we got 2 times radical 3 times radical 10 divided by 3 times radical 10, 3 radical 10 times radical 10. So guys, if we got two radicals multiplying with each other in the top, we just can multiply the inside. So we are just going to say 2 times radical 30, or 2 times 30 to the power of 1/2. Same thing, guys. And under that, we're going to get 3 times radical 10 times radical 10. And guys, this is something very important. If you got something radical and multiply with that same thing, radicals, doesn't matter if it's, it does matter, to be honest. If it's squared, you just can say square root of a squared since you multiply them. And if you have a square inside a radical, it will be a squared to the power of 1/2, and you just get rid of it, and you just end up with a. In this case, it's 10. So I would just say 2 to the power of 30, 2 times radical 30 divided by 3 times 10, which is 2 to the power of 30 divided by 30. I'm sorry, 2 radical 30 divided by 30. And you just can make it a little bit more simpler, and you just can say radical 30 over 15, because I just divided this whole thing with 2. So I just divided this with 2. I got 1 square root of 30 divided by 15, so I can make it more simpler. And that's my answer, guys. And last but not least, let's work on this question, guys. So the question is asking to simplify 6 over 5 minus radical 5. How are we supposed to do this? So basically, we're going to use our conjugates. Our conjugate means that in something like this, let's say a minus b, if we multiply this with a plus b, we would end up with a squared minus b squared. We just worked on it a few minutes ago. And then this is actually what we want to get, because we want to get rid of the square roots over here, guys. Maybe we can bring it to the top and we can make it more simpler. So I want to say 6 over 5 minus square root of 5 times, I'm just going to multiply with 5 plus square root of 5. The reason is being, I want to make it a square, and I can get rid of my square roots by my square. Don't forget, guys, if I got something squared, a squared, and if I got a radical, I can just say this is equal to that number, because basically it will be a to the power of 2 all the way to the power of 1/2, and they would just cancel each other out. So I'm just going to multiply with 5 plus square root of 5 divided by 5 plus square root of 5. And in this case, in the top, I would get, let's just write this in parentheses, 6 times 5 is going to be 30, plus 6 times radical 5 is going to be 6 times radical 5 divided by. Now it's getting to the tricky part. Also, guys, don't forget that I wrote the same thing, 5 plus square root of 5. So I will multiply actually with 1. This is 1. And therefore, I don't change anything in the real expression, so I can get my answer. And that wouldn't mess anything else. So in the bottom, let's start with multiplying. 5. 5 times 5. 5 times 5. 5 times 5 is 25. 5 times positive radical 5 would be positive 5 times radical 5. Now, I don't have anything else to multiply with. Now I get to the second number, which is negative radical 5. Guys, don't take radical 5 as a number. Take negative radical 5 as your number, because the sign in front of the number which you're working is actually what you have to take account for. So in this case, negative square root of 5 times 5, which will be negative 5 square root of 5, and negative radical 5 times radical 5 will be minus 5, negative 5, okay? Now, there is a beautiful thing down there, guys. I hope you guys noticed it. Now, we just can cancel 5 radical 5 with negative 5 radical 5 each other. They just cancel each other out. Now, we just end up with 30 plus 6 radical 5 divided by 25 minus 5. And this will be 30 plus 6 square root of 5 divided by 20. And also, we can cancel these zeros out. Actually, sorry, we can't. We just can divide this with 2 and make it a little bit more simple, but you can just leave it like this. Just notice that we had something, a radical under our fraction, and we were able to get rid of it by using conjugates. This is the point of this lecture, guys. So thank you guys for watching this lecture, and if you have questions, you can write a comment and ask me. If you need more, you can contact me on my email for tutorings, or you can subscribe and like for more videos like this. Please let me know what you want to get as a mathematics lecture, what what topic, what concept are you struggling with? We can work on it. So just let me know, guys, and thank you for watching. Have a good day.